everybody. So we're going to kind of look at 5.2, and 5.2 is a section where we learn how to verify trigonometric identities. Okay. So all the really fun stuff where we get to use the identities and we get to prove one side of the equation is equal to the other side. Okay. But before we do that, we have to know how to factor trig expressions. We have to know how to just kind of simplify trig expressions in general. So we're going to start with that. This section will be broken up into 3 or 4 parts. But let's just start with, say, number 4. And this says perform the indicated operation and simplify. So this one we have cosine beta times secant beta plus cosecant beta. Okay. So perform the indicated operation. They write it like this. Okay. I would say the indicated operation is probably to distribute first, right? So we would distribute, and I would have cosine beta times secant beta and plus cosine beta times cosecant beta. All right? And what we would want to do is kind of continue on simplifying this. So the secant beta, I would want to rewrite that as 1 over cosine beta. So remember, we have that reciprocal identity that says that the secant is 1 over the cosine. So we use that here. And we also have that the cosecant of beta is 1 over the sine of beta. So that's another reciprocal identity. Okay. Now, here, it might be kind of clear that the cosine of beta is going to cancel out, and you're going to be left with 1. So these two cancel out. That's ratio is 1. So I have 1 here. But then here I have cosine beta times 1. That's cosine beta over sine beta. Is really what this term is here. And what's cosine beta over sine beta? Yeah, it's cotangent beta, right? So that's our quotient identity, one of the quotient identities that we have. So this was 1 plus cotangent beta. Can we use our Pythagorean identities on that? No, right? Because that would involve 1 plus cotangent squared, and here we got 1 plus cotangent. So this is it. So that would be our answer to number 4. Okay? Oh, did not mean to erase that part. Pause the video if you need to kind of catch up writing that. But we're still kind of doing the same thing. Okay. So I want to look at number 6. So 1 over sine alpha minus 1, and then minus 1 over sine alpha plus 1. And we want to subtract those two fractions. Well, in order to subtract these two, I would need to get a common denominator. And if I have sine alpha minus 1 and sine alpha plus 1, really the only way I can get a common denominator out of that is to multiply this guy by sine alpha plus 1. Let me grab a blue marker here. So I would have to multiply this guy by sine alpha plus 1. And I would have to multiply this guy by what? The sine alpha minus 1. Okay, and this way I can get a common denominator, right? And then whenever you're dealing with subtraction, you just got to be really careful that you remember to distribute on this term over here. So right now we have sine alpha plus 1 times 1. That's really sine alpha plus 1. And then down here we have sine alpha plus 1 times sine alpha minus 1. And then here we have minus, and I'm going to write this in parentheses for right now still, sine alpha minus 1 over sine alpha plus 1 times sine alpha minus 1. Okay, and then do we have a common denominator? Yes. So we can combine these. So right now at this point, we're going to have sine alpha plus 1 minus sine alpha, and actually plus 1 minus times a minus 1 is plus 1 over my denominator. So this is if I add these two fractions. And at that stage, what does that become? Well, you can see the sine alpha minus sine alpha, that's just cancels, right? So this cancels. And then I've got 1 plus 1, that gives me 2. So I got 2. And then now that I can see that this denominator is really not going to cancel anything, I'm going to go ahead and distribute that back out. So this would really be sine squared alpha minus sine alpha plus sine alpha. Those middle two are going to cancel out. And then 1 times a negative 1, that's a minus 1. And the question becomes, what is sine squared minus 1? Okay, so here's where you need to be a little bit careful. I mean, we know that, let me just kind of off to the side down here, sine squared alpha plus cosine squared alpha is equal to 1. So if I were to subtract 1 and subtract cosine squared, I could know that sine squared minus 1 is actually equal to negative cosine squared. So you want to be really careful about your signs. So when I replace this by something, if I replace this by anything, it would have to be negative cosine squared alpha. So that's what we're going to do here. So this is actually 2 divided by negative cosine squared alpha. Okay. Now, remember that I know that if I have something like 1 over cosine alpha, that's secant alpha, right? 1 over cosine squared alpha is secant squared alpha. That means that if I kind of just think about moving this up, if I move this cosine squared up to the numerator, it really becomes secant squared. And I know this whole thing is negative. So what I really have is a negative 2 secant squared alpha if I move this guy up. And that is what I really have right here. And kind of the simplest way to write it. Okay, so I hope that is okay. Like I said, if you got any questions on these, because we're going to start doing some harder ones now, finally, just kind of ask me. We can go over any of these in a little bit more detail. Okay. Kind of doing the same thing. Okay, perform the operation and simplify. Same directions. I just have one like this. So this is cosine x over secant x plus sine x over cosecant x. And I want to simplify that. Okay, so I know 1 over secant is cosine and 1 over cosecant is sine. Really, one way I could think about this is if I move this secant up to the numerator, that becomes a cosine. So kind of write it out the long way. It's really cosine times cosine, if I move this guy up, plus sine. If I move this guy up, it becomes a sine. If I move cosecant up, it becomes a sine, right, by our reciprocal identities. So what do I really have? Right, this is just cosine squared plus sine squared, right? And what is that by our Pythagorean identities? That's just 1. Now, did I have to proceed in this fashion? Well, no, on the last one we did, we found a common denominator, and I could do that here. I could multiply this guy by, cosecant over cosecant, and this by secant over secant, and then add. I'm actually making a little bit more work for ourselves. So if I want to proceed by simplifying the fractions first and then adding, sometimes that's an easier strategy. But in order to really know the difference, you just have to have a little bit of experience kind of simplifying all these different kinds of expressions. On this one, if we kind of look at this option of rewriting these, we can see really quickly that it's going to be a Pythagorean identity. So we're salivating a little bit at that point, like, oh, it's 1. And eventually you look at this and you'll say it's 1 in a couple seconds, right? And that's going to be a lot of fun. Okay, let's look at another one. So number 12. So this is another one where we're just trying to simplify. So it says sine alpha minus cosine alpha squared. So whenever we have to the second power right there, one way we can do it is write it out and distribute. So I would write this out as sine alpha minus cosine alpha times sine alpha minus cosine, and then distribute. Okay? So this is going to be sine alpha times sine alpha, that's sine squared alpha. Sine alpha times negative cosine alpha, that's negative sine alpha cosine alpha. Cosine alpha times sine alpha, that's negative sine alpha cosine alpha. Negative cosine alpha times negative cosine alpha. That's a positive cosine squared alpha. Okay, let's take account of what we got. Okay, if I were to combine these two terms, the sine squared alpha plus the cosine squared alpha, what would that be? Yeah, that's 1, right? Because that's a Pythagorean identity. So if I combine these two, that's 1. Negative sine alpha cosine alpha minus sine alpha cosine alpha, that's a negative 2 sine alpha cosine alpha. That would be it. Okay. So time-wise, we're about 12 minutes. That's pretty good. Okay, I've got somewhere we want to factor. So this is really no different from like an algebra 2. But we've got trig functions in there. So maybe it looks different. Okay, so 13. Sine squared theta minus 1. Sine squared theta minus 1. Okay, so remember when we had x squared minus 1, and x was something squared, you could think of 1 as being something squared. And remember that was a difference of perfect squares. How did that factor? Well, it was like x plus 1, x minus 1, right? And we knew that worked out because x times x was x squared minus x plus x minus 1. Those middle two terms would cancel. So it's x squared minus 1. X squared minus 1 factors is x plus 1x minus 1. So if I have something like sine squared theta minus 1, how do you think that would factor just by kind of pattern recognition? This would just be sine theta plus 1. Sine theta minus 1, right? Because if I were to go through and distribute this, you don't need to write this part down, but sine theta times sine theta is sine squared theta minus sine theta plus sine theta minus 1. And those middle two cancel. Well, when I say factor, which is what I meant to write, this is our answer, right? We factored that expression. Occasionally, perhaps more than occasionally, that's going to be what we need to do, especially if we're going to try to solve some trig equations later or verifying some of these identities. We're going to need to know how to factor trig expressions. That's what we would have. Okay, let's take a look at, say, 17 here. And this one, if you want to pause the video and kind of try this first, you can. This is 2 sine squared x plus 3 sine x plus 1. Okay. So now, if you can either kind of just jump straight into it, or if you really have to, you can think about kind of the related quadratic first if it just looks weird. Okay. Eventually, you're not going to care. You can just jump straight in. But 2x squared plus 3x plus 1. Well, what are these first two terms going to be? Well, really the only way is 2x and x, right? So that makes it nice. And actually, the only way this can be a 1 is either -1 and -1 or +1 and +1. Well, all these terms are positive, so it really has to be this. And we'll just check. 2x squared times x, 2x squared. 2x plus x is 3x. 1 times 1 is 1. Right? So how would I factor this guy? Yep, it's going to be 2 sine x plus 1, and then sine x plus 1, just like I had over there. Okay. And you can check to see that's right. 2 sine times sine is 2 sine squared. 2 sine times 1 is 2 sine plus sine, that's 3 sine. 1 times 1 is 1. Right, so we got it factored. Okay. Let's look at another one. Say 19. Okay, cosine to the 4th plus 2 cosine squared plus 1. Okay, so let's kind of jump straight in and see, if I were to factor something like this and it was a x to the 4th plus 2x squared plus 1, what are my first two terms going to be? Well, they're not going to be just x anymore, right? Because I got to multiply to x to the 4th. So they're going to be like an x squared, right? X squared times x squared is x to the 4th. 2 plus 2 is 4, right? And then this is going to be a plus 1 and a plus 1. X squared plus x squared is 2x squared. So that's how I would factor something like this. So how is this guy going to factor over here? Well, it's just going to be cosine squared x plus 1, cosine squared x plus 1. Cosine to the 4th, cosine squared plus cosine squared is 2 cosine squared plus 1. Okay. Now, occasionally, I really mean occasionally, not too often actually, you may have to use the sum or difference identity. So remember, if you factored something like x cubed minus 8, some difference or sum of cubes. And I just want to refresh your mind on what those formulas were. Okay, so for a sum of cubes, something of the form a cubed plus b cubed, that is going to factor as a plus b, a squared minus ab plus b squared. So we have that formula. Okay, now it's kind of the magic one. Oh, if you don't believe it, distribute and see that it's the same, right? I imagine you did that in Algebra 2. And that's called the sum of cubes formula. There's also a difference of cubes formula. Okay, and this guy is a cubed minus b cubed was a minus b, and then a squared plus ab plus b squared. So kind of the funny story is that at high school, our math teacher never told us that there were actual formulas for these. So I kind of remember doing a lot of these. And at one point I said, well, there's a general pattern. And I said, I think there's a formula for this. And he just kind of laughed. I think he was holding back on us a little bit. But so I thought I discovered a formula that, of course, was around before that. But he's like, no. No, I just like you guys to think about it instead of memorizing the formula. But these, assuming we have these results, what we want to do, 21 is sine cubed x minus cosine cubed x. All right? So, and I think these are relatively kind of hard if you didn't know the formula to pop this out. It's not as intuitive as maybe you would think. It's like a difference of squares, okay? But for this one, I'd use this formula, and my a would be like sine, and my b would be like cosine. So kind of using that formula, this would be, let me just say like my a is sine, and my b is cosine, right? So I'm just kind of plugging in. So this would be sine x minus cosine x A is sine, so it'd be sine squared plus AB would be plus sine x cosine x. And then, am I out of room? Almost. What's the end? It's plus cosine squared, right? Did I get it in? Okay, good enough. All right. So we're in. And that would be the first part. Of course, though, if I have this, the sine minus cosine, I can't do anything with. But what's sine squared plus cosine squared? That's 1. So I would combine those two, and I would get 1 plus sine x cosine x. And I would want to go ahead and simplify that once I factor. So this would be at the end. Okay. All right, so you will be seeing some more problems and kind of writing your answer out and sending me a picture of it instead of doing Alex for this part, because I want to make sure that you are that you've got this part down. Okay, so I've got to end this video. It's over 20 minutes now. I'll see you.